Assalamu alaikum students. Structure questions on kinematics and dynamics. IGCSE 0625. This is the topic of my today's video. One video is already uploaded on the same topic, but that was from 5054, that is GCE O levels. So the topics are same and questions are a bit similar, and the students may be benefited from both the videos. Both the videos will be helpful to both IGCSE and GCE O levels. So the questions which I have chosen are typically related to the graphs in kinematics, majority of the questions, and the questions which are included in this video are starting from 2017 up to 2022. So let us begin with our video and the topic. The first question which I have taken from IGCSE is from May-June 2017, variant 41. The question is related to the speed time graph, and it is related to both kinematics and dynamics. You know that the kinematics is the study of motion of the bodies, and we don't talk about the forces which are involved. Body accelerates, we do calculate acceleration, but we don't talk about the forces. But of course, whenever a body accelerates, there will be a resultant force acting on the body, and Newton's second law is applied. So the questions which are included, they have use of equations in kinematics. That is the first equation of motion. V is equal to u plus at, S is equal to Vt, and the use of Newton's second law of motion and some conceptual questions related to the topics. So here this is a speed time graph for an ice skater. So in the beginning, as shown in the graph, the skater is moving with the constant speed of 11 meter per second. Explain what is meant by deceleration. So deceleration means decrease in velocity. Okay, if this is uniform deceleration, then it means the velocity decreases at a uniform rate. Same decrease in velocity with respect to same interval of time. So it's of only 1 mark. So what we will write here in this, that is decrease in velocity. With respect to time. Use figure 1.1 to determine. This 1.1 means here this is the question number 1 of that year. And this question is question number 1 in my worksheet also. And inshallah, I will upload the link of this worksheet in the description box. So you can download it later on. So let us see what is the next part B of the question. The distance traveled between time t equals to 3 seconds and 6 seconds. So we have to calculate the distance between 3 and 6. So 3 lies here between this 2 and 4, and 6 is there. Because this is a uniform deceleration, so we have to calculate the distance which is traveled when the ice skater decelerates. So the working of the graph is already plotted, and I am going to show in red line. I have marked the position of this 3 seconds here and 6 seconds. So this is area of the trapezium. That formula is half into sum of the parallel sides. Parallel sides 11 and this is 5. And the distance between the parallel sides. The distance between the parallel sides 3 to 6 means 3. So the answer is coming 24 meters. The next part, the deceleration between t equals to 3 seconds and t equals to 6 seconds. So for the deceleration, what we will do, we will apply this formula. A equals to final velocity. Final velocity, because he is decelerating, the final velocity is less than the velocity at 3 seconds. Velocity at 6 seconds is 5 meter per second and velocity at 3 seconds is 11. So 5 minus 11, that is minus 6 by 3 is 2 meter per second square. Because I have used a, so I will write minus sign. But with deceleration, we do not write minus sign here. So we will, what we will write simply here in this, we will write simply 2 meter per second square. Show what happens to the size of deceleration after t equals to 6 seconds. The deceleration is decreasing. You have seen the graph is becoming less steeper. So deceleration decreases. And why, what happens to the resultant force on the skater after t equals to 6 seconds? The resultant force which was acting in the backward direction is also decreasing. That is why the deceleration is decreasing. So I have added marking scheme as I added in my previous video. I will add the link of the video uh, that is also related to kinematics, but from GCE. The total marks are 7 here. This is the marking scheme attached here. Now question number 2, that is 43, variant 43, May, June 2018. So there is no atmosphere on the moon. A space probe is launched from the surface of the moon. Figure 1.1 shows the speed time graph of the space probe. In my worksheet, this is question number 2, but of the paper, it is question number 1. So this is the uh, speed time graph of the space probe. So you can see from the graph, the shape tells that the graph is becoming steeper later on. So you have to calculate the acceleration at time t equals to 0. So at t equals to 0, we have to choose the time up to which the acceleration is uniform. Means only up to there is you can see the graph 100 seconds. That means the middle is 50. So up to certain position, the graph is a straight line. One small division will be equals to 10 small divisions are 50, means two small divisions are 10. So the working of this is also done. I will show here this. So this is uh, the acceleration and the change in velocity from 0 to, so this is 1000. 10 divisions are equal to 1000 means 4 divisions are equal to 400. Initial velocity 0 here, and the velocity at 30 seconds is 400. So 400 minus 0 is equal to 400 divided by 30 minus 0. So the acceleration is coming equal to 13.3 meter per second square. And since the data is in having two significant figures, so you can write 13 meter per second square in this. So acceleration here 13.3 meter per second square. 13 meter per second square. We have taken the time interval up to which the acceleration is uniform. Later on, the acceleration it starts changing. Between time t equals to 0 and time t equals to 150 seconds, the acceleration of the probe changes. Without calculation, state how the graph shows this. Graph is no more a straight line. The gradient of the graph is changing. Okay. Gradient changes. During this time, the thrust exerted on the space probe by the motor remains the same. State one possible reason why the acceleration changes in this way. Because the probe is using a fuel and fuel is used up. So it means the weight, the downward force is changing. Mass changes. So it means the weight changes. So because when the space probe travels upwards, of course, it makes use of the fuel which provides chemical energy and the thrust. So part of the fuel is used up. So the weight of the space probe changes. Calculate the distance traveled by the probe from time t equals to 200 seconds to time t equals to 300 seconds. So this working is also done 200 to 300. So this is uniform deceleration. Mm. So we have to calculate here. Here I have divided into two parts, that is triangle and rectangle. So in the triangular part, this half into base into height. So what is this base? 200 to 300 means 100, and this interval is 4100 and 4100, and this is 5000. So 5000 minus 4100 is 900. So height is 900 and base is 100. So this is the area of triangle. And because we calculate the distance by calculating the area under the graph, we can make use of trapezium also, or we can have triangle plus rectangle. So here I have done using triangle and rectangle. So the rectangle 4100 is the height and 100 is the width. So 4100 into 100. So the total is coming 4.6 into 10 to the power 3 meters. So this is our working. We can use the formula of trapezium also. So we will get the same answer for the question. So this is the marking scheme. So we have calculated the tangent, that is the straight line portion of the graph. Okay, and then in the beginning, the space probe was slower, and later on, it accelerates more. So acceleration is increasing due to the uh, decrease in mass of the space probe, because when it travels upward, it makes use of the fuel. So the mass decreases, so does the weight. Okay, so gradient changes or the graph is curved. That is the part why the acceleration is not uniform. Mass of rocket decreases or gravitational force, and this is also the possible answer. That is, when it goes higher and higher, the value of g will also decrease. So there may be due to the change in mass or the change in the weight due to the value of g, which may change when we go at higher altitude. Okay, so the this area is calculated. So here the formula, you can use the formula average speed into time also. Okay, so you can see the marks which are awarded. Area under the graph you have to mention, and then you have to do the proper calculation and the final answer with appropriate unit. Okay, now question number 3. This is again question number 1 of the year. The question is from variant 41, May, June 2018. And this is of a vehicle which is accelerating from rest. And its acceleration in the beginning is greater and acceleration is decreasing, unlike the previous case where acceleration was, because the graph was less steeper and later on it becomes more steeper. Here it is more steeper in the beginning, and then later on its acceleration decreases and then it decelerates. The There is a similarity in this part of the graph where the vehicle the probe was decelerating, and here the vehicle is decelerating. So calculate the acceleration of the vehicle at time t equals to 30. When you see time t equals to 30, it comes between 20 and 40. Okay, and the graph is not a straight line, so you can't simply do this way, that is taking this 30, and because sometimes student, they don't calculate the gradient, they simply take 30 and they do it. This is mm, let me locate properly. So 20, 30. So of course my line is not coming straight, so this is the point somewhere here. So the tangent has to be drawn in such a way that the tangent touches the curve at 30. Okay, and this distance, this point position is to be noted, and this position is to be noted. So final velocity, initial velocity, time, and this time. Okay, so this is done in a proper manner already. I will just show. Question number 3. See, this is the gradient which is drawn. Tangent is drawn at 30. The red line is showing the position of 30 seconds, and the point where this time is 30, the tangent is drawn touching the curve at 30. Okay, so this final velocity, which is equal to 24, and initial velocity of this, that is 6. So, and time, the time at this is, um, there are 40 to 60, means 5 divisions are equal to 20. Means this is 44, 48, 52, 56, 60. So this is 56. 56, and initial time, one small division is 4. So this is the working is shown here, 26. 24 minus 6 divided by time, y2 minus y1 over x2 minus x1. What is the formula of the gradient? Y2 minus y1 over x2 minus x1. So the gradient is calculated, and that is coming 0.35 meter per second square. Let us see what next part says. So we have calculated the acceleration. Without further calculation, state how the acceleration at time equals to 100 seconds compares to the acceleration at time equals to 10 seconds. Suggest in terms of force a reason why any change has taken place. Let us see the graph again. In the beginning, there was a greater acceleration, and later on, the acceleration decreases. Velocity is not decreasing, acceleration is decreasing. That means the rate at which velocity is increasing is decreasing. So, why this is happening? Without further calculation, you don't have to calculate, you just have to compare. In the beginning, the acceleration is greater, and later on, at that is at 100 degrees Celsius, 100 seconds, the acceleration is smaller because graph is less steeper, and at 10 seconds the acceleration is greater, so acceleration is decreasing. Why this is happening? It means resistive forces are increasing. The forces which oppose the motion of the vehicle are increasing. The backward force increases, so resultant force in the forward direction decreases. So there are 3 marks for this question. It means there should be 3 points here. First should be the answer. What happens to the acceleration? Acceleration at 100 seconds is less than, you can simply let acceleration decrease. Less than, this 1 mark for this. A at 10 seconds. And why this happens? Resistive forces, friction, air drag, resistive forces increase. Because when body accelerates, the resistive forces also increase. They adjust their value with the speed of the vehicle, with the speed of diver, etc. So resistive force increase. So resultant force in the forward direction, I am not writing forward, in forward direction decrease. So acceleration is due to unbalanced force. So that unbalanced force in the forward direction decrease. So this is like 1 mark for writing what is acceleration, whether acceleration at 100 seconds is greater or smaller, then what is the reason, and then conclusion of this. So this carries 1 mark. So later on you have to calculate the distance traveled by vehicle between time t equals to 120 seconds and time t equals to 160 seconds. So the working for that part is already done. I will just show the working of this part. This is on the graph. That is a distance. So for the distance, I have used distance. Let me have a look at the question once again. Determine the distance traveled between 120 and 160 seconds. So 120 and 160. This is marked in yellow color. It's a trapezium. So I have used the formula of trapezium, half sum of the parallel sides 30 and 20 into the separation between the parallel sides. So this is 160 and 120 means 40. So this calculation is done and the distance is 1,000 meters. So this is done. This is of 3 marks. So you can see the marking scheme is attached here. Acceleration is less driving force or greater resistive force. Okay. Resultant force is less. Area under the graph, 1 mark you have to write down, and the distance traveled. Here they have used triangle plus rectangle or both. That is the trapezium as well, 1000 meters. Next question, that is from October November 2021, variant 41. A train of mass 1.8 into 10 to the power 5 kilogram is at rest in a station. At time t equals to 0, the train begins to accelerate along a straight horizontal track and reaches a speed of 20 meter per second at t equals to 15 seconds. Okay, so at t equals to 15 seconds, the speed becomes 20 meter per second. And this is which graph is shown. Let us see. The train continues at that speed of 20 meter per second for 10 seconds. At t equals to 25 seconds, the driver applies the brake and the resistive forces on the train causes it to decelerate uniformly to rest in further 24 seconds. Let us see. So this is a distance time graph. The up till now the graphs which we have discussed in previous three questions, they were velocity time graph. So this is a distance time graph. Okay, so it means the question she says that it reaches 20 meter per second at t equals to 15 seconds. So it means we have to find out what will be the distance at that time. Then we can draw the graph correctly. Okay. So it's an incomplete graph. Of course, they will ask us to complete the graph by drawing a line to represent the motion of the train between t equals to 15 and t equals to 25. Because this is mentioned in the question, uh, it is accelerating, and at t equals to 15 seconds, it acquires the speed of 20 and it continues going with that speed of 20 meter per second. So distance time graph for a constant velocity will be a straight line. So that will be straight line starting at t equals to 15 up to t equals to 25. So that is easier part, and done for you also. I'll be doing here just to show where is t equals to 15 coming. Somewhere here. This is 10, exactly in between. This means, but where it should be, I should know the distance. At what distance this will be the speed. So I can't just guess it, but this is to be a straight line. So straight line means something like this. Okay, then a same manner because velocity is constant. So this is also done already. I will just show how this was done. And a curve to represent the motion of the train between t equals to 0. This was accelerating up to t equals to 15 seconds. And calculate the kinetic energy. That is another part. Let us see the graph of this. Question number 4. See here, I have calculated the distance which will be covered when the time is 15. So the velocity they have already mentioned that acquires a speed of 20 meter per second at time t equals to 15. So velocity, and that velocity remains the same up to 25. And what is the distance covered up to 25? You can see this is 320, 200. In between, this will be 320, and it's one small division on y-axis representing 5 meter. Wait a minute, 200 and 300 comes in between. One small division is 20 meters. Okay, one small division along y-axis represents 20 meters. One small division. Y-axis is 20. So this midpoint is 300, and so this is 300. So this is the distance which is covered here. And uniform distance means we can make use of formula what? S equals to Vt. So V is equal to s over t. Time interval between 25 and 15. 15 and this is 25 somewhere here. So that is 10. Time interval is 10. The distance at 25 is 320 and this distance at 15 is to be found out. Okay, velocity is 20. So 20, 320 minus x over 10. So that is coming 120 meters. So where the distance is 120 meter, this is the distance 120 meter. So we have to start our straight line from this distance. Okay, so straight line is to be started from this t equals to 15 where the distance covered is 120 and t equals to 25 the distance is 320. Okay, and during this interval the velocity remains 20 meter per second. This was given in the question. So this is the uh, working. Have you have seen this? Now let us go to the next part. What is asked in the next part of the question? Calculate the kinetic energy of train between t equals to 15 seconds and t equals to 25 seconds. So we will make use of velocity is known to us. We will make use of formula Ke equals to half mv square. Half into, let me check the mass of this. Into V. V is 20. Whereof 20. So 400 means 200 into m. So mass value has to be seen. 200 into m, mass of the 1.85 into 10 to the power 5 kilogram is the mass into 200. So we will get this in our marking scheme, or 1.85, 1.8 into 10 to the power 5 into 200. 1.8 into 10 to the power 5 into 200. That is 3.6 into 10 raised to the power 7. 3.6 into 10 raised to the power 7 is the kinetic energy. While the train decelerates to rest, it does work against the resistive forces and its kinetic energy decreases. Define work done. Work done is force into distance moved in the direction of force. This our kinetic energy value 3.6 into 10 raised to the power 7 joule. Force multiplied by distance in direction of force. So we have defined work done, and let us go to the next part of the question. What is asked? Determine the distance moved by. So what we will do, we will make use of the formula. The kinetic energy 3.6 into 10 to the power 7 joule, and F into D. The force, the resistive force, calculate the resultant force. First, determine the distance moved while it decelerates. So this will be done by area under the graph. Okay, the distance moved by the train when it decelerates. Let us see the graph. So here the distance is 560, and while decelerating, where the deceleration begins after this 25. T equals to 25 seconds. It goes with the uniform velocity and then it decelerates. From here, it starts decelerating. So what is the distance? At this time is 320 and this is 560. So the distance covered is 240 meters. Okay, and then in order to calculate the force, we will use the formula F into D. So the force is coming 1.5 into 10 raised to the power 5 Newton. So here the distance moved is 240, and the force is 1.5 into 10 raised to the power 5 Newton. And distance 240 meter, and this was where 240 equals to 1.5 into 10 raised to the power 5 Newton. I will show the graph again. How did we calculate the distance covered while decelerating? The deceleration time is here. Okay, it is given. After that, this stops. Okay, so that distance is 560 meters, and this distance when it starts decelerating is 320. So the difference is 240 meters. This is the marking scheme. Kinetic energy calculated, distance to 40 meters. And then because work done is equal to force into distance, kinetic energy becomes the work done. The work which is to be done to stop the car will be equal to the kinetic energy which the vehicle was having. A ship sails in a straight line between two ports. Figure 1.1, again it will be the question number 1 of this year, October number 2021, variant 43, shows the speed time graph of the ship for the first 100 minutes of its journey between the two ports. Okay, so it means the ship is starting from zero. It is accelerating in the beginning slowly, and then it accelerates at a uniform rate, and then afterwards it goes with the constant velocity of 15 meter per second. This is what we analyze from the graph. At what time the constant velocity begins? that is t equals to 60 minute. Here, this is minute, not second. So we have to take care of this. And the speed is in meter per second. So this time is to be converted in seconds. Calculate the maximum acceleration during first 100 minutes of the ship's journey. So the graph is again plotted already for you. So this is the graph, and this graph shows what was to be calculated in the first part, maximum acceleration during first 100 minutes of the ship's journey. So when you see the graph, first 100 minutes. So this 100 minutes, of course, the acceleration is not constant. Where the acceleration is constant at t equals to 100. Okay. So this acceleration is to be calculated. This is the maximum acceleration. And when does it start? It starts at around, you can say, t equals to 40. Okay, at t equals to 40, the straight line begins, or earlier than this. So this I will just show the working is done. So here the time which I have taken is, see, there are 10 divisions equals to 20 minutes. So it means one division will be equal to, what will see here, one small division is equal to, this is 20. So one small division is 2. So it is 42. Okay, so that 42 minutes. Minute is to be converted into seconds. The uniform acceleration begins. This line is a straight line. Okay, and the final speed is 15, and speed at 42 minute is, if you see, this is 5 and this is 1. Two divisions, one small division equals to 2. So 5, two small divisions are equal to 1. So 5, 6, 7, 7.5. Okay, so this is 7.5, and acceleration change in velocity 15 minus 7.5. And what is the time at 15 when the speed is 15 meter per second? That is 60 and 42. So the acceleration is calculated, and the answer, and it is this time is converted into seconds by multiplying it with 60. Okay, so 60 minus 42 is 18. 18 into 60. This is coming 0.0069 meter per second square. So this is the time, and this is the acceleration of the 0.0069. Calculate the total distance traveled by the ship between t equals to 40 minutes, 42 minutes, and time t equals to 100. So this we will calculate by using area under the graph, and this already is done for you. Let me delete this part. This was answer of this previous part. So this area distance between 42 minutes and 60 minutes when the speed becomes 15 meter per seconds. So wait a minute. Let me check the question once again. 42 and 100. Sorry, not 60. 42 and 100. So this is different shapes. So I have divided into two parts, trapezium and rectangle. Okay, so area of trapezium, sum of the parallel sides, one is 7.5, the other one is 15. Okay, so 15 plus 7.5 into divided by 2 into the separation between the parallel sides, that is 42 and 60. 62 minus 60 minus 42 is 18. This is 18. Okay, sum of the parallel sides, and this is 15 and this is 7.5, and this is rectangle 15 and this is 40, and the time is to be converted into 60. Here this is time 18, 18 is to be converted into 60. So this is area of trapezium is 12150, 12,150, and area under the rectangle is 36,000. The total is coming 41850 meters. So distance traveled is also calculated. You can see the answer once again. 48,150 meters. So you have to express into in two significant figures. So that will be 48,000 meters. At the time, as at a time not shown on the graph, the acceleration of the ship is 0.0087 meter per second square. The total mass of the ship and its passenger is 2.3 into 10 to the power 7 kilogram. Calculate the resultant force. So how will we calculate the resultant force? F is equal to ma. F is equal to ma 2.3 into 10 raised to the power 7. This acceleration which is shown is not shown in the graph. 0.0087. So what is the resultant force coming equal to? 2.3 exponent 7 into 0.0087. So the answer is 100 Newton. So you can write 2 into 10 to the power 5 Newton. Explain why the force on the ship due to ship's engine is greater than the value you calculated. Of course, there will be the resistive forces due to water, okay, which will be opposing the motion, will be in the opposite direction. So the to keep the acceleration constant, the ship has to have greater force, greater forward force. Okay, engine has to be providing greater forward force so that the resultant force remains the same to maintain the acceleration. Okay, so due to the resistive forces which will act in the opposite direction. So to maintain the constant forward force, he has to the driver or the ship's engine has to provide greater the actual force. This is the resultant force, and resultant force is what? Forward force minus resistive forces, opposing forces. I am writing here. R is showing resultant. Okay, so it means this has to be greater. The force which the driver is applying, that will be sum of the opposing forces plus the resultant force. R plus friction or drag force or opposing forces. So you must have noticed that we are making use of equations of motion as well as the Newton's second law. You can check. So this answer 2 into 10 to the power 5 Newton, that is the force. Okay, and the backward force is there. So it means to keep the constant acceleration or to maintain to keep the constant acceleration, the engine has to provide greater force whatever is needed. Okay, the next question, variant 42, May June 2022. So here this is related to light gate. Uh, okay, figure shows an object of mass. This is question number 2 of that year. 2 kilogram on the bench. This object is connected by a cord passing over a pulley to an object of mass 3 kilogram. Okay, so this 2 kilogram object is attached to 3 kilogram object. So of course this will be applying force and this will be moving in this direction. In which direction will this be moving? In this direction, and the weight will be going in the downward direction. Due to this weight, the weight is applying this force and it's going in the downward direction. 2 kilogram object is released from rest and accelerates at 4 meter per second square. Calculate the resultant force on the 2 kilogram mass of the object, 2 kilogram object. So what will be the resultant force? F equals to ma. Mass 2 into 4 equals to 8 Newton. This is the resultant force acting on the 2 kilogram object. Calculate the upward force exerted by the cord on the 3 kilogram object. We'll have to see the figure once again. This object. Okay, so weight is acting vertically downward. And in new papers, we have to take weight G equals to 9.8. But in this paper, we can take value of G because this is of 2022. We can take the value of G equals to 10 Newton per kg. Okay, so the weight is 30. Okay, and what is asked? Calculate the upward force exerted by the cord. What is the upward force on the cord? This F is to be calculated. So we have to calculate the upward force F on the mass of 3 kilogram. Here you have to remember one thing, that is the acceleration, because both masses are attached. So acceleration which was given in the question is 4 meter per second square. So both objects are having the same acceleration. So what is the resultant force on this 3 kilogram mass? So resultant force on 3 kilogram mass is 3 into 4, that is 12 Newton. Hmm. Okay, so and weight is 30 Newton in downward direction. So what will be the value of F? Value of F will be 30, which cord is applying on the mass. 30 minus 12 equal to 18 Newton. Yeah, so the because both masses are attached by means of a rope, so acceleration both of the masses, 2 kilogram and 3 kilogram, are having the same acceleration. The objects have constant acceleration. Show that the speed of the object 0.8 second after release is 3.2 meter per second. So here we will use the formula A is equals to V minus U over T. Acceleration is 4 equals to final velocity is to be calculated, and they started from rest. So 0 over time interval 0.8. So V equals to 4 into 0.8 is equal to 3.2 meter per second. So which is proved. Let us read the next part of the question. A card with the of width 2 centimeter is fixed to the 2 kilogram object. As the 2 kilogram object moves to the left, the card passes through a beam of light that is perpendicular to the card. Using the speed given in C1, calculate, that is 3.2 meter per second, calculate the time taken for the card to pass through the beam of light. So card has a width of 2 centimeters. So centimeter is to be converted into meters. And the move to the left with the constant speed, and it cuts the beam of light. So calculate the time taken by that car to pass the beam of light. So the width is 2 centimeter, means the distance moved by the card is 2 centimeter. This is 2 centimeter. So the beam which is passing through this, that will be blocked for the distance of 2. So S is equal to Vt. The time is distance is 2 centimeter, means 0.02 meters equals to 3.2 into t. So 0.02 divided by 3.2, that is coming 6.25 into 10 raised to the power 3 minus 3 seconds. Yes. 6 point. I'm not sure whether I've taken the right value of speed or not. Anyhow, 6.25 into 10 raised to the power minus 3 means 6.3 milliseconds. Let us have a look at the marking scheme. Yes, this is, I have taken the right value of speed. Okay, the force 8 Newton, 2 marks for this. Then the upward force exerted on the mass of 3 kilogram. Change in acceleration, change in velocity divided by time, that is the speed was to be calculated. So this is now done. All the marks are